Hello and welcome to this video where we will discuss the future of combat aviation, that is sixth generation fighter jets. These are aircraft that are being developed in all major regions of the world with technological ambitions that are gradually being revealed but which are relatively similar everywhere in the world. Before discussing the technical details, let's examine the various ongoing programs, beginning with the most developed ones. Specifically, the American Next Generation Air Dominance includes two aircraft, one for the Air Force, with a few images in the corner of a virtual hangar, from a Lockheed Martin video, and one for the United States Navy, which would be based on Boeing's FA-XX program. At least the United States isn't making the same mistake they did with the F-35 by putting all their eggs in one basket. Here they're still going with two separate programs, one for the Navy and one for the Air Force, and so the Air Force program, it officially started in 2014 and it has already made its first flight with the goal of entering service as early as 2030. So there are many voices in the United States calling to speed things up and really develop much more quickly. This sixth generation aircraft program, the development is going well with costs under control and a clear commitment to high technological ambition. And the goal would be to extend the lifespan of fourth generation aircraft. I refer you to the previous video where we talked about this topic. And to move directly from the fourth to the sixth generation, by cutting the F-35 fleet, which has ongoing development challenges and inflated costs in procurement, development and operation. With more than 42,000 euros per flight order. The second program, which should be completed chronologically, is the Tempest, which is scheduled to enter service in 2035. Initially, two distinct programs existed, the Tempest, uniting Great Britain, Italy and Sweden. On one hand, and on the other side, there was Japan, which was developing the FX with Mitsubishi, but there was already a sharing of a certain number of elements in particular. Rolls-Royce was to provide engines for both aircraft and develop electronic warfare as per agreements. And by meeting on a number of points, the two programs eventually ended up merging, with the ambition to fly by 2035, making the program more credible due to the relatively fast timeline. Because the British budgets to develop this sixth generation aircraft were objectively too low to successfully achieve this rapid goal. On the other hand, Sweden has disappeared from the agreements, so we don't know if they will stay in this agreement with Japan or if Sweden will join another program. Why not the other European program, which is obviously called the Next Generation Fighter, which is part of the larger program, Future Combat Air System, the Future Combat Air System. But what is a system of systems? And sometimes we call the Next Generation Fighter the Future Combat Air System because it's the keystone of this program. And so, under the leadership of Dassault, with Airbus, which brings together France, Germany and Spain, with the ambition to have it in service as early as 2040, China aims for a plane by 2035 despite political statements targeting 2030. But technically, it would more likely be 2035. But there isn't any information about the plane's specs or the manufacturer involved in its development. We just have a few 3D images where you can see a flying wing without a tailplane. And there are full-scale models that are displayed at defense exhibitions. Although we know they're developing these planes, it's not a credible or tangible reality for now. And American intelligence services say that the Chinese are going all out for this development. India, for its part, would rather focus on improving its advanced medium combat aircraft, which is a fifth generation aircraft currently in development, and they want to gradually integrate sixth generation technologies into it. And if you remember what I told you in the previous video, that's exactly what they're trying to do with the Rafale, where they're going to adapt certain sixth generation technologies to integrate them into the Rafale. So it's something that's completely doable if the aircraft is well designed from the start and it allows for this incremental increase in capability. The Russians, on their side, they've mentioned the defense assistance package. But given the difficulties that are now objectively almost insurmountable with the Sukhoi 57, with the engines, with electronic warfare, the development of this aircraft, which began around the same time as the F-35, has faced numerous challenges in various areas. The United States has delivered many of them with the known difficulties I've described several times. But Russia today doesn't even have 10 Sukhoi 57s that are capable of flying. So imagine that it already manages to launch itself in 15 years on a generation that's even more advanced, with all the difficulties it's facing in Ukraine and the decrease in operational capability that's linked to recovering electronic warfare pods, targeting pods. The Allies recovered entire Sukhoi 34 planes from those shot down over there. Russia must start from scratch on several concepts, making it unlikely for them to develop a sixth generation aircraft. So maybe they would depend on China for the future of their combat aviation. So have you seen all these programs? At least on the outside, they have a relatively similar look. It's a flying wing with a design optimized for stealth, similar to the Deux, which pioneered this shape that appeared ultra-futuristic at the time. Unlike the predictions in movies like Steels from 2005, where there was a plane with a forward-swept wing and canards that you have under the nose of the plane, which improves its maneuverability. Well, that means the disappearance of all the fins and canard planes. With a few questions, however, about the next generation air dominance, since you can see on this diagram that there is the possibility of maybe having a movable part on the trailing edge of the wing that could extend to offer more maneuverability, and that could potentially retract again to restore the aircraft's full stealth. So, besides the flying wings, this shape is basically the same everywhere. The second main feature of 6th generation fighters is their size, which is necessarily much larger than 4th generation aircraft, since all the bombs and pods have to fit inside the internal bays rather than under the wings. To give you an idea, the model of the SCAF, which was presented at Le Bourget in 2019, it was 18 meters long with a wingspan of 14 meters, compared to 15 meters long and 11 meters wide for the Rafale. The weight difference is particularly noticeable. The Future Combat Air System would be 20 tons empty compared to 10.5 tons empty for the Rafale, and obviously, when fully loaded, 38 tons for the Future Combat Air System, 23.5 for the Rafale. So, the important consequence of having a plane that's logically much bigger is, for example, for France, that everything is sized according to this plane, the hangars and everything else. But also the next generation aircraft carrier, meaning the future carrier, will have to accommodate planes that are much bigger. So a runway that's also longer and wider. That's why the porte-avions de nouvelle génération, the next-gen aircraft carrier, must be 75,000 tons rather than the 42,000 tons of the Charles de Gaulle carrier. But besides this stealth, which involves specific shapes, materials and sizes, the 6th generation could also have stealth, which relies on a plasma envelope that absorbs all radar waves that might try to hit it. That's a feature we already see on some hypersonic missiles, so the plasma forms in a fairly natural way, but it can also be generated in particular. China would be developing this technology to prevent hypersonic missiles from overheating, because this form of plasma helps avoid air friction and therefore reaching thousands and thousands of degrees. If we stick to communication and stealth, there's also an interesting element, which is laser communication. It's a technology that's quite common between satellites in space, and it's also used at short distances. You may be familiar with Li-Fi, a technology used in airplanes. It makes things simpler, avoids wiring, but here we could use it between devices. And little by little, it's developing to cover greater and greater distances. And for example, the United States Air Force has already validated the control of an MQ-9 drone by satellite. I mentioned it to you in an Air and Cosmos press review a few months ago. I'll share the link with you again. The big advantage of laser communication is that it's unjammable, it's undetectable, and then, unlike exchanges that happen over radio, well, we remain completely discreet, meaning it's directional, whereas with radio, basically anyone around you can detect that someone is transmitting over the radio. And so that's how you get discovered. Incidentally, we have ultra high speed. It's a bit like fiber optics compared to digital subscriber line, which would mean that there could be ultra high definition video feedback, for example, to a command center. But why not send the information back for analysis at a command center instead of putting artificial intelligence on board the aircraft with all its required computing power? When it comes to weaponry, we're mainly looking at hypersonic technology. That will truly make a difference. The phase of the war, just like the missile that fires beyond the horizon, changed the face of aerial combat with the arrival of the F-14. I refer you to the previous video about 4th and 5th generation aircraft. But today, this hypersonic technology already exists in missiles, RR, with the Air Intercept Missile 54 Phoenix in the United States, which came out in 1974, or with the R-37 Soviet missile in 1985. These missiles exceed Mach 5 and are designed for large targets like refueling planes or airborne warning and control system. They are not used in standard air-to-air combat. And the goal would be to further increase the speed and range while obviously minimizing the size of these missiles, which until now have had to be carried under the wings and will have to be carried directly inside the fuselage in the famous bays to remain stealthy. For everything that is air to ground. Russia leads with the Kinzhal missile, launched by the MiG-31, reaching Mach 10. And the United States, on their side, they also have to deploy systems very soon, since the tests have made good progress. For its part, India will soon have an airborne version of the BrahMos, which will be air-launched. Several countries are developing these technologies, including some unexpected ones like Taiwan, which aims to be self-sufficient in this field. So, you see a kind of proliferation all over the world, with many countries considering it strategic to master hypersonics. In Europe, there's a bit less development, and here it's France that stands out with its progress. From the replacement of the air-sol moyenne portée améliorée, which is the nuclear missile currently carried by the Rafale, and which will be tomorrow, the ASN-4G, which will be available in 2035. So it's a hypersonic technology. But for now, France has decided that it will be limited only to its nuclear deterrent. Among other sixth-generation weapons, there's one that really captures the imagination: directed energy weapons, which are often referred to as laser beams. So, at first, it's simply about protecting the aircraft against incoming missiles. And that's basically the principle behind directional infrared countermeasures, which I've already told you about, in which the beam will dazzle the seeker head of the incoming missile, causing the missile to be lost. Commercial airliners, such as all Israeli and presidential aircraft, are already equipped with directional infrared countermeasure systems. So it's a technology that is already fully mastered. An infrared countermeasure pod can be found under one of the Sukhoi 57 prototypes. It would be the first fighter jet on which it's being tested, at least for now. In the United States, they're focusing on developing pods that could be installed under various aircraft, including the F-16, as you can see in this video. But the ultimate ambition is to develop an offensive capability at a significantly longer range. We're witnessing increased development of lasers that can destroy more than just drones. Also in Israel, they're going even further with what's called Seram, which is a laser capable of destroying even mortars. So, we're already dealing with a much higher power, and ultimately the ambition would be, why not, to be able to destroy ground targets without needing missiles, shells, or anything like that. With necessary developments, of course, in terms of laser beam capacity and electrical generation, which are going to be much higher, and with a cost that is clearly much lower. One last point about armament, but it's really the overall weapon system around the aircraft. It's the availability of drones to support the aircraft. So obviously we're thinking about large wingman drones, a bit like the Royal Wingman, which is being developed by Boeing in Australia. This concept is likely the most advanced globally, as it features onboard artificial intelligence that enables decision-making without pilot input. It will adapt to the current mission. But there are also many programs to have a lot of small drones that could be released in a swarm. And they should allow both to saturate enemy defenses, but also to have remote sensors or effectors in some cases. And for example, MBDA has already unveiled two serial mode carrier models called the RC-100 and the RC-200, which are dedicated respectively to the SCAF and the Airbus A400M. If we now move on to the whole set, all the issues of detection, you have to understand that the era of well-defined sensors is over. That means we have direct access to the skin of the aircraft, its surface, which will be a kind of large antenna capable of collecting all the information about its environment thanks to nanomaterials and a skin made of composite materials. And that's what we call conformal sensors, so it's not just about detecting radar waves or light flashes anymore. The goal is to have 360-degree visibility, allowing the pilot to perceive changes on the battlefield, or to allow the pilot to redefine the requirements of his mission without having to call a command center. Thanks to a 360-degree tactical view, but also a strategic view of the entire situation. But with all this information that will be collected, there is a need to be able to analyze it on board the aircraft and therefore potentially to have onboard artificial intelligence. That's what we call edge computing. To put it simply, there is an evolution. In the past, reconnaissance missions involved planes flying over specific areas and automatically taking photos. You had to return, land, and specialists would analyze the information. In the more recent version, for example, what is used on the Rafale, the information is transmitted in real time to the ground. And there are still analysts who have to watch it in the standard F4 version of the Rafale. There will be an onboard artificial intelligence that will be able to detect targets of opportunity. This enables real-time handling instead of waiting for an analyst's review. It can take up to 3 hours to send a plane or drone back to the area, which is what we're waiting for. On 6th generation aircraft, so this 6th generation technology will be integrated into the Rafale. As time passes, sensors will improve, and artificial intelligence will be able to detect everything around it. And this expertise is very clearly widely publicized by the aerospace manufacturers Lockheed Martin, British Aerospace, Dassault Aviation, obviously with the possible integration of this system on the F-35 as well to improve the aircraft's detection capabilities in the infrared spectrum. The aircraft will have to fly in an atmosphere that will be much colder, and so that means they will have to fly much higher, probably above 20 kilometers in altitude. This requires advanced engines with unparalleled complexity compared to the past, designed to emit minimal heat to avoid detection. Because we detected, we realized that when a vehicle moves between 800 and 1,000 kilometers per hour in the atmosphere, the air heats up to a certain temperature, which is detectable when you're very, very high up. And so that could potentially allow these future 6th generation fighter jets to be at high altitude. And to see all the fighters, all the drones, all the planes that are flying around them, below them. And so, at that point, they will have interception and detection capabilities that are far superior to those of their opponents. With a potentially much greater range as well, because the higher you are, the farther your detection capability will be. High altitude radars can see farther than ground-based ones. The same applies to planes with large sensors. So, besides these unmatched detection capabilities, there will also be an intention for 6th generation aircraft to be integrated into cyber warfare. It's not just about electronic warfare, where you turn off radars or jam them remotely. Here, the goal would be to directly integrate into this network digitally to be able to insert data packets into it. That means making it believe false information by making echoes disappear or appear by moving the targets it is about to process. The goal is to make the tactical situation incomprehensible for the enemies. So you see, 6th generation aircraft is a concept that today is revolutionary in many different areas. But you have to understand that it's the cornerstone of collaborative combat. The aircraft is integrated into a system of systems, and it's the one that can be considered the flying data center, capable of working with all the devices connected to the network. And so, it's a concept that we call multi-sector collaboration. So in order to achieve a complete view of the situation, in an environment more complex than ever before in history, the machine interface must be completely revised, particularly considering the errors observed with the F-35. There were too many touch screens and no more physical controls. 20% of the operations were performed in the wrong place on the touch screens. The same applied to voice commands, which were particularly unsuitable and unusable during dogfights. So, we're moving towards integrating eye tracking, which means we'll be following the pilot's gaze. Flight simulators already use it for training, but now it will be integrated into the aircraft themselves to be able to display information in the right place to draw the pilot's eye to the correct angle. And also what's called neurofeedback, which would allow monitoring of the pilot's brain activity. The goal is to adapt to his understanding of the situation, to his fatigue, to adjust his workload to his actual cognitive capacity. In a future phase, consider the possibility of giving commands directly by thought. And so in the United States, for example, you have Collins Aerospace, which is already developing a helmet called the Zero-G Helmet-Mounted Display System, plus for fighter jets. The next generation air dominance must provide a panoramic view in the visor. Improve the pilot's perception and abilities to interact with their environment in a mission that is of a complexity never before reached in the history of aviation. Because in addition to everything that flies and is already integrated into the mission and used, which appears on the screen, you have to understand that future missions may also call on additional devices. For instance, the helicopter drones can be directly dropped by 400M. Validation tests were conducted there at the end of last year. But this means that we're no longer just dealing with the devices that are part of our mission and can be used. We have additional ecosystems that can be added if we want to do reconnaissance as well, if we want to do electronic warfare, if we want to do bombing as well. And that's very clear. In terms of visualization, the European Future Combat Air System project is the most advanced. Since we have this combat cloud that integrates all the military forces, It treats each actor as a sensor or effector based on requirements, integrating radar networks, artillery, armored vehicles, satellites, ships, drones. Everything will be connected. So you see, the sixth generation fighter is part of a profound modernization of our way of waging and perceiving war. And this evolution also relies on the omnipresence of drones. And in this sense, what we are seeing in Ukraine is clearly helping to define the doctrine of high-intensity warfare that we will see in the coming decades. But all these operational requirements require starting from scratch. That means we're not just talking about an evolution of current aircraft. We need many significant technological breakthroughs. Flying at very high altitudes without emitting heat, mastering stealth through plasma, deploying directed energy weapons, implementing artificial intelligences. And for each of these fields, it is essential to remain among the world leaders. Obviously, in order not to become a target of a country that might be aggressive. Sadly, their numbers are growing worldwide. But also because we expect economic benefits that are absolutely enormous for those who master technologies like graphene, artificial intelligence, microelectronics, quantum, lasers, and high energy density batteries. And so that's why the development of these planes amounts to 60 to 80 billion euros. But beyond the absolute requirement for defense to master these tools, we are also investing to guarantee hundreds of thousands of high-tech jobs until the end of the century. In France and in Europe, obviously. According to the widely recognized Cercle des Économistes, let me remind you of this figure. In France, we have a defense spending multiplier of 2 after 10 years. Which means that every billion euros invested in the defense industrial and technological base generates an extra $2 billion in gross domestic product over a decade. So these are investments. It seems to cost a lot, but in reality, we also expect a lot of returns. This includes the civil industry with high-tech companies like Airbus and Ariane and everything related to them. Well, that's what we're buying by investing in the next generation fighter in the Future Combat Air System for the coming years. I hope you enjoyed this video. We will soon interview a top specialist involved in this program, welcoming him to the Air at Cosmos studio. This way, you'll see his technological perspective on airplanes and their use in the coming decades. We're discussing an aircraft that will be in service until 2100. Once again, thank you for always being so numerous. Subscribe if you haven't yet.